Algebra 2. Today's learning targets on dividing complex numbers. Number 1. Never leave I, imaginary number, in the denominator of a fraction or a division problem. Never leave I underneath the fraction bar. To get rid of it, you're going to have to do rationalizing. Rationalizing the denominator means that you're going to multiply both the top and the bottom of your problem by I or by the conjugate. Conjugate means that you're going to change the sign of the middle term. There's two ways to rationalize a problem, which means get rid of the imaginary number. If the problem has one term underneath the division bar, you're going to multiply both the top and bottom by I. If the problem has two terms underneath the division bar, you're going to multiply by what's called the conjugate. And the conjugate is you changing the sign of the middle term. Again, our learning target today is on dividing complex numbers. So question number 1, example 1. We have 10 divided by I. Since we know from the past that I is the same thing as the square root of -1, that's the definition for it, and we've also learned that we cannot leave radicals underneath division bars, then we can't leave I underneath a division bar. So we're going to have to rationalize by multiplying the top and the bottom by I. If this is one term, that is the way to simplify it. The reason that we are allowed to multiply the top and bottom by I is because I divided by itself is actually the same thing as 1. So multiplying any problem by 1 is not going to change the problem. When you have a fraction times a fraction, you're going to multiply straight across. So it's 10 times I, which is 10I, over I times I, which is I squared. Next step, you're going to drop down your 10I, and you're going to change the I squared to what it's equal to, which is -1. And then next and last step would be you dividing 10 by -1, because we never want to leave a negative number underneath a division bar. It's just not simplified. So 10I divided by -1 gives you the final answer of -10I. So when you have a division problem, you notice the division bar, and the term underneath the division bar is just one single term, like an imaginary number, the best way to get I off the bottom is to multiply both the top and bottom of the fraction by the letter I. When you go straight across and multiply, what should happen is the denominator will change to a real number, and then you can simplify. Question 2. 9 plus 3I divided by -3I. Again, focus on the bottom. This is one term. It is -3I. We want to get I off the bottom. So what we're going to do is the same thing we did in number 1. We're going to multiply the top of this problem and the bottom by I. Again, repeating what I said in number 1. The reason this math trick works is because I divided by I is 1, essentially, and multiplying a problem by 1 does not change the problem. So we're not trying to change the problem, we're just trying to make sure that the i's are gone off the bottom. Now, what I want you to notice on top is that we have a complex number. Here's the real part and here's the imaginary part. Complex numbers have two terms. I'm asking you to multiply it by I. So this is one term times two terms. We're used to seeing the one term like in front and just distributing. So we're going to have to do this distributive property backwards. So it's I times 9 and then I times 3i. I times 9 comes down first, and that's going to be 9i. I times 3i is 3i squared. In the next step, we'll change that over. Now we're going to multiply the bottom. Negative 3i times I. Well, negative 3 times 1 is negative 3. I times I is I squared. Okay, next step. We're going to change the I squareds over. So top, you're going to drop your 9i down, your plus 3, and then I squared, change it over to times by negative 1. In the bottom, or on the bottom, you have negative 3 I squared. We're going to write negative 3 times negative 1. Okay, back to the numerator. Notice how I'm doing one step at a time, and that way you're less likely to make a mistake. So you're going to drop your 9i down, and then 3 times negative 1 is negative 3. Denominator, negative 3 times negative 1 becomes positive 3. Okay, notice right now that this step does not have an I on the bottom, and it also does not have a negative number on the bottom, which is good. The last thing I do want you to check, however, always check to see, are these numbers that I'm highlighting, do these numbers reduce? Okay, so a lot of times people like to think of it like this, like 9i minus 3 divided by 3. If you want to break this up into two fractions, you're only allowed to do this when there's a single number on the bottom. You can think of it like 9i divided by 3 minus 3 divided by 3. If it helps you see it better, that is an option you have. But your goal is to simplify these numbers. 9/3. So 3 will go into all of these numbers I've highlighted. So because you can find a number that will divide nicely into all of them, you do need to reduce your fractions. 9i divided by 3 is the same thing as 3i. Negative 3 divided by 3 is the same thing as negative 1. And so that is a better simplified answer than this one. Okay, but they actually do equal the same thing. So again, on number 2, I had a single term on the bottom. To get rid of the I rationalized, meaning I multiplied the top and bottom by I. The top I had to use distributive property since this one had two terms. Bottom I just multiplied straight across. I then had to change I squareds over to negative 1 in the next step. I then simplified, and then when I got to this step, I realized that my numbers that I highlighted I should be able to reduce them, and this was the best answer. Okay, so number 1's answer was negative 10i, and number 2 is 3i minus 1. All right, let's try number 3. Number 3, notice that on top, and we'll put parentheses around this, we have a complex number again. Here's the real part, and here's the imaginary part. Then we have a big division bar, and on the bottom, we see another complex number, 3 plus 4i. Because I have a binomial, two terms, or because it's a complex number, I can't treat number 3 like I did number 1 and 2. Here is why. And this part I do not want you to write down. I'm just showing you why this will not work. The whole goal to rationalizing is, again, to get that I off the bottom. Notice if I kind of think ahead, if I were to go to the bottom right now and multiply I times 3, I would get 3i. And multiply 4i times I would get 4i squared. Well, the I squared is going to change over to a negative 1. Just kind of quickly showing you how I'm thinking about it. And this 3i is just going to stay 3i. And so essentially this is going to be 3i minus 4. And the problem is I still have an I underneath the division bar. So me multiplying by I over I, which did work in number 1 and 2, does not work does not work when there's two terms on the bottom. Okay, so that plan didn't work. So I'm going to erase everything here. And that's why in the notes, I've typed it up this way. Or some problems you'll have to multiply by the conjugate. And again, the conjugate is you changing the sign of the middle term. So here's what I mean by that. The problem on the bottom is 3 plus 4i. The conjugate of this number is 3 minus 4i. So again, you're changing the middle sign. This one's positive, this one's negative. Whatever you put on the bottom, you have to multiply the top of this problem by the same exact thing. Because remember, we want this part to just be 1. 3 minus 4i divided by itself is just 1. Alright, next, you're going to notice the numerator has 2 terms times 2 terms. You're going to do FOIL right now. So first would be 5 times 3, and you do need to be patient and take your time, show every step. Outside is 5 times negative 4i, negative 20i. Remember, we're in multiplication mode, so we can multiply anything together. Next is inside, negative 2i times 3. That's negative 6i. And last is negative 2i times negative 4i. Negative times negative is positive. 2 times 4 is 8. I times I is I squared. So the top is done. We'll simplify it as, for right now. Let me rephrase that. The multiplication is finished, but we'll have to come back in a minute and simplify. Now our i's are going to move to the bottom. We're going to do first 3 times 3. Write down your 9. Outside is 3 times negative 4i, which is negative 12i. Inside is 4i times 3, which is positive 12i. And last is positive 4i times negative 4i. Positive times negative is negative. 4 times 4 is 16. I times I is I squared. Remember, when you are multiplying and you see letters, you're adding the powers. That's where that's coming from. Alright, as of right now in question 3, I am finished with the FOIL method. So now my brain switches from multiply mode to add subtract mode. I want to go back to the top and notice that the 2 I'm underlining are like terms. They're both imaginary. So what we're going to do is drop our 15 down, and we're going to go ahead and put negative 20i minus 6i together. We are in add mode right now, so that would be negative 26i. You're then going to drop down your positive 8 and switch I squared over immediately in this step to negative 1. Now focus on the bottom. Please notice that these 2 terms match. They're both imaginary. One has a net coefficient of negative 12 and the other is positive 12. Negative 12 plus 12 is 0. 0i means there's no imaginary number left in those 2 terms. So you get to cancel them. And you're going to drop down your 9 and your minus sign, and then your 16, and then the I squared again changes over to a negative 1. Alright, we're going to keep trying to make every step look better. Now on top, back to the top, I've got a real number here, and I've got a real number here after I multiply them. So this is going to be like 15 minus 26i, and then 8 times negative 1 is negative 8. Again, I'm showing every step. Now our I switch to the bottom. This says 9 minus 16 times negative 1. Well, we drop our 9 down. I do the multiplication first, of course. And so I'm going to multiply negative 16 times negative 1, which is positive 16. So let's put a plus sign. Positive 16. Alright, we are getting very close to finding the answer. The next thing you do Go back to the top and put your real numbers together. 15 minus 8, that would be 7. Drop your imaginary number down. That would be negative 26i. And then denominator, 9 plus 16, that would be 25. Okay, please notice right now, denominator, that's the part we got to be real careful on. Notice there is no I, and notice it's not negative. So those are two good things. And the last thing I want you to check for before you call it quits is you look to see, will these numbers that I'm highlighting reduce? Is there a number that divides into 7, 26, and 25 at the same time? The only numbers that divide into 7 are 1 and 7. 7 does not divide into either one of these, and so because of that statement, that means that this is the best answer. It cannot be reduced any further. Okay, and notice number 3 is the longest type because you do have 2 terms on top, 2 on the bottom. You're multiplying by the conjugate. Again, the sign has to be changed. What that allowed to happen is after I did FOIL, the i's on the bottom canceled for me, which is what I wanted to happen. And then I was able to achieve the goal. Okay, all right, now we're going to move to question 4. Get rid of this. Okay, so question 4 is 8i on top divided by 2 minus 5i. I see one term, imaginary number on top, and a complex number on the bottom. I'm going to go ahead and put parentheses around the complex number. Because there are 2 terms underneath the division bar, then number 4 is like example 3. I can't multiply by just I have to multiply by the conjugate on top and bottom. The conjugate of 2 minus 5i is 2 plus 5i. So that's what I'll multiply by. Okay, all right, let's go to the top first. Because I see one term times 2 terms, I'm just going to use distributive property here. Distribute means I'm multiplying, so we're in multiply mode. 8i times 2. And we drop down the answer for that. Now we do 8i times 5i. 8, positive 8 times positive 5 is positive 40. I times I is I to the second. Denominator, I see 2 terms here and 2 terms here, so we're going to do FOIL. So first would be 2 times 2. Outside is 2 times 5i. Inside is negative 10i. And last is negative times positive is negative. 5 times 5 is 25. And I times I is I squared. All right, next step. We'll bring our division bar down to separate it. Our i's go back to the top. We notice an I squared popping up, so we're going to change that over. We're going to drop the 16i down, plus 40, I squared changes to negative 1. Notice I keep doing the same thing. We go to the denominator. I see 2 imaginary numbers in the middle. One's a positive 10i and one's a negative 10i. 10 minus 10 is 0i, meaning I do not write it underneath the fraction. I drop my 4 down. I drop my minus 25. I see I squared popping up again, so I'm going to change that to negative 1. Okay, we go back to the top. 16i and then a positive 40 times negative 1. So we're going to drop our 16i down. 40 times negative 1 is just negative 40. Since this is imaginary and this is real, we can't put those together. So that's as good as it gets on top. Denominator, we drop our 4 down. We multiply negative 25 times negative 1. Negative 25 times negative 1 is positive 25. We go back to the top. Again, nothing can be done there, so we're just going to drop that down. And then denominator, I see 2 real numbers. Well, they need to be put together. 4 plus 25 is 29. And then the last thing I do before I call it quits is I check out these numbers and see, is there any number that will divide evenly into 16, 40, and 29? If there is, I have to simplify. I have to reduce the fractions. If not, I can leave it. Numbers that go into 16 are 2. 2 won't go into 29. It'll go into these, but not this one. So it has to go into all of them for you to simplify. 4 goes into 16. 4 divides into 40, but 4 does not go into 29. 8, yes, yes, and no. And 16, no and no. Alright, so that looks like this has to be the answer. 16i minus 40 divided by 29. Okay, so again, today's learning target was on dividing complex numbers. There's really only 2 types. You have to make sure you understand. When the denominator is one term, like question 1 and 2, please just multiply the top and bottom by I. When your problem has 2 terms in it, please multiply by what's called the conjugate. Change the sign in the middle. Be careful on your multiplication, the FOIL method. Make sure you show every single step. Notice in my notes right now, my models, I didn't write any equal signs. I'm working down the page. That's exactly what I want you to do on your homework. Okay, so do not try to work these left to right on your paper to save paper, because you're going to lose. It's going to be easier for you and I to lose our places. Make sure you show work underneath, just as I modeled here. Okay, and just take one step at a time. Don't get in a big hurry. And like I said, you'll be less likely to make a mistake. And our goal is to understand these and, of course, get them right.